Good evening to all. I take this opportunity to warmly welcome you to the third day of our faculty development program. We are delighted to have our esteemed resource person, Mr. Gunakar Rao sir, and enthusiastic participants with us today, and we look forward to a fruitful learning experience. I would now like to invite my co-coordinator, Ms. Sivani Jana, to briefly introduce the resource person of the FDP to all. Thank you. Thank you.
Thank you, Archana ma'am. Good evening, everyone. It is my privilege to welcome Mr. Gunakar Rauje, a highly accomplished in civil engineering with over 30 years of service in the Water Research Department. He holds a master degree in structural engineering from Osmania University and a bachelor's from Andhra University. He has contributed significantly to major projects like the Pulichintala Dam and Veligonda project, with expertise in design of irrigation structures, quality control, and the use of engineering software such as StartPro and NISA Irrigate. A recipient of the Republic Day Meritorious Award 2025, Mr. Gunakar Rauje is also a respected trainer who has delivered lectures at ESCI and FPARD. We are honored to have him with us today to share his insights and vast experience. Finally, I request Mr. Gunakar Rauje sir, please take over and begin the fifth session of this FTP. Thank you all for your presence and support. Please, sir.
Oh, good evening. Okay, as introduced, I'm executive engineer Pulichintala project. When Gopinath ji has introduced, asked me to, take a lecture on this. See, generally academicians, you people would be definitely, more theoretical and background, all that exploration would be there with you. So I asked, how come I come for this in this area of giving a lecture on this topic. Then he said he just asked me to just share my experience in this respect, but directly I have not experienced in FRC area, but as explained, like in my 30 years of experience in the department, I have come across so many problems, and also I'm part in fortunately for a part in solutions, solution finding issues also. But I take this opportunity to convey my views rather than like a lecture. I want to just share my views in this respect, and a few aspects where this FRC has been used in our department. So that will definitely be helpful, and it will be a practical experience I can really share with you people to discuss on this topic. Okay. Okay, Shabinaji, Shabinaji, can I share my?
Yes, sir, please.
Are you able to, say this?
Yes, sir, it is visible now.
It is visible. Okay, right.
Please make it full screen.
Okay.
Yes, sir.
So before pardon?
Yes, sir, it is all right.
All right, fine. So basically, before I go into the practical experience and my views on that, I want to just throw some light on fiber reinforced composites, like what they are and what we are discussing about. Like now with definition, see, like FRC, as we all know, it's a mixture of a fiber with matrix. Generally, I want to see, I don't want to make it like an academic discussion, but I want to, I prefer to, convey my views like a discussion. So generally when I thought some fiber reinforcement has come into civil engineering, I thought like how it could be replaced. See, traditionally our steel, concrete, these kind of members, all structural members, we are just we could envisage only with fiber like steel and concrete. But when fiber reinforced, how it can be replaced? Initially we thought, but when we see like a fiber, with its material property mixing with a matrix like resin like thing, combining together could give that structural strength, rather stiffness. I was really astonished. When I listened to for the first time how the FRC could really can be introduced into the as a structural member. But you see, it is nowadays. See, after a lot of experiments and with great, introduction of FRC into structural, like as a fiber, how it could really, import such a strength when it is mixed with resin-like thing. Giving the property. See, generally what we see is when a material replaces the existing traditional material, we always compare. Like, what are the mechanical properties of the introduced member? Can it really replace? There could be some, disadvantages, but still we see, to what best we can do. Of course, economics always play a major role, but here, when a strong fiber, when it mixed with a weaker matrix, would give the structural, material property, our required material property of to take care of the all structural aspects. So that's fantastic, really. But okay, few things like cost wise, all that now we have to discuss in detail. Also, when it comes to our department, generally in department, what we see is when a new material, when it is introduced, see, we have to prepare data, and economics we have to study, and we have to get it approved at higher level. Usually our technical advisory committee would be there, and we submit all this to them, and unless until we get approval, we cannot just directly adopt any new compound, any material rather. So it also should serve the purpose other than our routine purpose. So where actually, in our department, this FRC is introduced, in fact. So that's I will discuss in detail with you. But when it comes to fibers, like as we all know, glass fiber, carbon, and aramid fiber, and basalt fibers, all these fibers with a matrix, like some epoxy resins, when they are mixed together, would give the property of our material that we really require for our structural requirement. Okay, here fibers are like carbon. Generally, see, it's a strong, but that has with the a carbon, with the carbon content, there will be a rusting property and all. But glass is such a beautiful thing. Like there won't be any issue, but its brittleness has some problem with us. Like how it is now solved by using a polymer with glass, and we got that ductility, and how we are overcome the problem of each individual. If it is used individually, we cannot serve our purpose, but in combination we could really make it. That's what the beauty of this fiber reinforced composite. So fibers are like, what basically the fibers we use basically for strength and the stiffness. So these would be served. See, generally, though it is not desirable, we go for certain deflection. Like that stiffness we always look for apart from strength, because of XYZ reasons, due to impact and all. That also a property that is required. We sometimes discuss in our technical discussions, like why this has come into picture for our structural aspects. yes, it has a, I mean, major role to play with. So I mean, that is required, I mean, which is basically imparted by our fiber in our material now. So aligned to carry the load, and obviously your tensile strength. See, like I mean, when even a, I mean, iron rod, like I mean, which is such a metal which can really take the load, is also, I mean, at certain point it get yielded. So here that high strength can be, I mean, achieved by a fiber is a beautiful thing. But here, I mean, when it is bind with a matrix, like I mean, like a resin and all, it's giving the beautiful property of fiber reinforced composite. Okay. And protects the fibers from environment, generally transfers the load between fibers also. Yes, yes. So here what we should discuss is, like I mean, here actually a simple sentence here, what it speaks is like generally from particle to particle, how it transfers the load. When we analyze, like I mean, how the particle it is transferring the load onto the, I mean, adjacent particle, and overall how the entire load is taken care by the entire structure. Here when generally our fiber, I mean, carries the load, but here through the binding material, the basic load, it would be transferred into to the fiber. So also it protects from, obviously, from environment. It protects. Okay. When it comes to advantages, like what all, see, before we go for a new new material, we obviously look into what are the advantages with it. Generally, when compared to generally used material, which is practice in vogue, we look for what the advantage is, like high strength to weight ratio. The first point when we discuss, see, I mean, one of our, I mean, designer used to always say, see, we are designing for more dead loads rather than live loads, because our structure weight itself is enormous in our concrete structures. So the dead weight is more, and we are taking care, suppose a beam we are designing. So obviously your self weight of the beam is huge. Like for a, I mean, bridge, if you design a deck slab, so deck slab thickness is, I mean, very considerable. I mean, for which we have to design rather than the live load. So of course, live load with impact is considerable, but when we see, like your dead load will be more there. So here we can reduce this, I mean, weight. So high strength we could achieve with low weight ratio, I mean, with low weight. So this point we have to consider when we adopt this kind of I mean, material. So that's what I feel here. Like I mean, high strength to weight ratio, that is more significant when we go for a fasces. Also we can reduce, but there are certain issues would need to be, I mean, addressed, like when we adopt a new material. But here when for designing a deck slab or for a beam and all, so this aspect we have to take into consideration, since the weight would enormously be reduced with the same strength that we could achieve with the traditional material that we are using, that we have been using rather. Okay. Then corrosion resistance. Yes. So when you see corrosion resistance is very, I'm sorry. Okay. So corrosion resistance. Generally, this aspect is very significant, because generally I being an irrigation engineer, all 90% of my structures are in contact with water. So all water retaining structures like piers, I mean, abutments, like I mean, retaining walls, and most of the structures, my tanks, my, I mean, boxes, box kind of structures, troughs, all these are like they're with, I mean, water carrying I mean, components. So any exposure of I mean, reinforcement, it's prone for rusting. So the corrosion is the most important factor for me. See, nowadays, like I mean, now we are still thinking because of the cost aspect, but otherwise we can directly adopt a MNCRP of fiber reinforced glass fiber reinforced bars, we can directly go for, because rusting won't be there. Even there are honeycombs, or even it is a coastal area where there is it is prone for corrosion and all, where you can really use this kind of material. Without any doubt, when we conform with all other aspects, like strength wise and all other aspects, like all mechanical properties, whatever it is. So that aspect we have to, that is most advantageous with FRC. And then tailorable. Yes. See here, generally, steel, of course, with its metallurgy, you can change a little, but here it is when there are two different components, they are when mixed together, you can made it tailor made. Like whatever the properties that are required, you can do it. So even the process is easy here. Since the process is easy, you can directly adopt. You can even order the material for with such a property with which you really want to make use rather. So that is one major advantage with the FRCs. And when it comes to fatigue resistance, see, this is also a very important factor I really want to discuss. Because normally fatigue, when we now discussed, like the yield point when the load is applied continuously when on a member, or it will be subjected to fatigue. But here, since we use fibers, that fatigue resistance is much more. See that after you are reaching to the maximum load, the fatigue resistance would be more. Suppose, let us say we allow to the deflection with which it can be, the structure can be subjected to. But at that point, when we introduce load like that, at certain point there is possibility, if there are cracks, if already honeycombs are there, because of the fatigue loading, at that point of time, there is every possibility that if a small crack develops, that will propagate. But in case of FRC, that we can overcome, because of fiber integrity, there is no possibility of crack development, and even that fatigue would not continue and further propagate your crack or whatever it is. So that is and beauty of FRC, because here that fatigue resistance is really considerable when it comes to FRC rather than our traditional steel. Steel, where see it would take the load, but when concrete get cracked, or because of any reason, see, construction, it is not in our hands. There is every possibility of honeycombs and not proper mixture at a particular section. If it is the critical section, let us say, so it's vulnerable, but that can really be overcome with your fatigue resistance. That's it. That's one most important aspect that we have to discuss. And when it comes to low thermal expansion, yes, because of glass, because of fibers low conductive property, it has very obviously low thermal expansion. So see, suppose if I design deck slab, sometimes I require to have continuous. Generally, we provide expansion joints at regular intervals and all, even for retaining walls and deck slabs for continuous. See here, you have to consider this thermal expansion, taking that alpha into consideration. You have to find out L alpha T, that delta L, and with that strain and the corresponding stress you have to consider, and that you have to import, and you have to take care of your design. So that much. So every increment of your thermal expansion, you have to take care through your design. But here with our FRC, you can reduce that. Here with low thermal expansion, you have less stress that would be imparted you through your temperature rather. Yes. Okay. Applications. Basically, we being civil engineers, let us. So I don't know, like what the group is like, but I being a civil engineer, we emphasize more on it here. All obviously for your bridge decks, and yes, seismic retrofitting. here, due to, I mean, earthquake resistance would definitely be more, because see, our most of our I mean seismic failures would be obviously shear failures. Your, I mean, lumped mass that that would be applied would I mean impart cracking. But when we, I mean, as we discussed, like this would definitely for retrofitting it will be more useful, because see, wrapping up structural elements, rather jacketing. You might have already, I mean, heard about when some I mean retrofitting is done to the existing columns or existing beams. I have I mean literally done. I have designed and also I have executed piers which got I mean wrapping is done, like I mean jacketing to the existing structure. See, but because of that, we do have some hydraulic problem. See, generally, if the existing pier, if it is wrapped with certain jacketing, suppose a certain thickness would be there, and because of that, your ventway will be reduced between the piers. So thereby, I mean, my hydraulic efficiency will come down. Say there would be head loss will be there. My, I mean, hydraulic aspect I have to look into, where if I can reduce this, I mean, jacketing thickness, so that is very, I mean, advantageous for me. Suppose wrapping up any structural, I mean, element like pier, if I could do with the FRCs, FRP, I mean, with I mean fiber reinforced polymers and all, with I mean slight, I mean with thin layer, you can serve the purpose. So thereby, I can really go for retrofitting of the project. See, in most of the projects, because of hydraulic aspects, there are cases even structures got dismantled to I mean overcome my hydraulic problem, to have the, I mean ventway earlier to the prior to the retrofitting. But here, using FRP, that can be, I mean, that we can overcome. That is one advantage with I mean FRP wrapping of structural elements. Here, the strength and ductility and resistance to the seismic forces. Yes, obviously, as we discussed, and with these properties, with the mechanical properties of this, we discuss one by one. But that can really, I mean, serve our seismic forces. And due to its weight, obviously, in aerospace, like I mean, aircraft fuselages and wings and satellite components can also be see their that weight, obviously, I mean, is very serious, very expensive, because I mean fuel cost, it depends on the also depends on the material that we are using for those airspace aircrafts and all. So that will definitely be helpful there. And in automotive, sport cars and electrical chassis they are using. And in sport equipment also, weight it gives measure. See, that much of strength it would be required for rackets and all. But I mean, with less weight, that can overcome. Okay. So that is the advantages in the applications of our structures. Yes, of course. So there are how many types of fiber reinforced composites that are available here, and obviously glass fiber reinforced polymer, carbon, aramid, and of course even composite hybrid composites, and steel fiber reinforced concrete, and of course synthetic reinforced concrete. So these are all the see, based on the fiber that you are using, it could be called by that name. So if it is carbon fiber reinforced polymer and all, and we'll discuss one by one. So glass fiber reinforced polymer, obviously stronger, and with its density it is lighter in weight when compared to our steel, and less material obviously needed. See here, it has the strength almost when we compare, like I mean sometimes 1.5. See, it depends, like I mean what kind of polymer you are using, that combination. So obviously, I mean it's much stronger when compared to that weight, and obviously less weight is needed. But see, in the recent past, but in the department when we use, I mean we have not reduced the size, though we have used this, but initially as an experiment we have not taken that risk. But you can definitely, I mean, bank on the properties that it has got, and we can definitely reduce the size of the structural member. Okay, that's what we have discussed. I mean, that is our ultimate goal, to have less less volume of the component. Okay. Cost saving. See, definitely not. Cost saving, it's impossible with these kind of materials, because these are definitely expensive. But at times, see, for the purpose when it is served, as I discussed, like, I mean, for corrosion and all, see, your repetition of, see, in the long term, definitely it could be cost saving, cost effective. But I don't think when it is initially used, yes, there would be, I mean, initial burden would be there with the department, with government exchequer. I mean, to invest more for the initial execution and all, generating both time and money saving. Yes, see, this you can say to some extent, because see, I mean, carrying steel and doing all scaffoldings and your rod bending, all that would be there without, I mean, in this. So there might be saying, like, I mean, when we use bars and all. Okay. So other also, I mean, obviously with your weight, your cost would be reduced when we go for data. It all with respect to your weight. So your labor cost, your machinery cost, all with respect to weight. Suppose if you, I mean, adopt a crane to lift, actually, I mean, so if you, instead of a 30-ton crane, now a derrick crane may, I mean, serve the purpose. Obviously, your rate would come down. Your rate analysis, with your rate analysis, rate would come down. So obviously that would be there. But overall, the basic component cost is expensive. So obviously it will be more. But okay, in the over a period, obviously that saving would be there. Yes. This you can say, I mean, eco-friendly, durable material allowing to design for a long lifetime of the structure. Yes, we should agree with this in respect of rusting and all, and as no maintenance nor repair work. Yes, let us see. Like, I mean, with no repair work, yes, we do appreciate that. And glass fiber reinforcement, the FRP. Further, okay. So definitely it is sustainable. This is what our basic motto. With significantly less energy. Okay, CO2 emission obviously would be less. And since steel, if it is molded and if it get casted into bars and all, obviously that is a very, I mean, robust procedure which we follow. But it is, I mean, with pultrusion, just pull and extrusion method, we generally prepare this glass fiber reinforced polymers and all. So that is a simple process when compared to, I mean, steel manufacture and all. So thereby we can say it's I mean, sustainable in that aspect. Also, obviously your transportation and all that insulation would be a little cheaper. Okay. And then non-corrosive and non-conductive, that property is there, which we discussed. Material that doesn't corrode. And also, yes, the other aspects are like, I mean, it is resistant to chlorides. So that's why we are saying, I mean, in coastal areas and all, this is most, I mean, advantageous when we go with these structures, because every now and then we have been retrofitting, or we are almost replacing the structures, replacing components. So this is a very advantageous with when humidity is there in humid zones and all. This is most advantageous. So non-conductive, yes. Suppose in powerhouses and where more power lines would be passing nearby, it is really advisable to go for GFRP. When sometimes we feel like, I mean, we try to avoid passage of very heavy, I mean, voltage lines adjacent to our, in pump houses we come across. Generally in powerhouses and pump houses, when we design structures, we try to avoid adjacent to beams and all, because if there is any if sufficient power and all, it is not there, it is most vulnerable and it is most dangerous in since high voltage currents would be passing in the nearby, and also in magnetic fields when they are passing. So this is more useful. Yes. So when it comes to carbon fiber reinforced polymers, obviously high strength, and carbon imparts a very high strength, but and of course the stiffness. Here carbon fibers with obviously in polymer with polymer matrix. See, this is it depends on the the material with what kind of properties that is required. See, in future it would be there if you have a number of pultrusions and here and there, if the really GFRP CFRP, GFRP, all these are prepared. Like for our requirement, you can order. That's how it would be in future. You can really envisage such a future with fiber reinforced materials, so that you can go for. And carbon fibers provide a primary strength, obviously, since carbon is very hard, and stiffness to the composite. And CFRP is significantly lighter. So significantly, obviously, we should say that when compared to our steel, and is beneficial applications with weight reduction is crucial. Yes, and obviously corrosion resistance, but it depending on the metallurgy that we are using. So that should be, depending on where you are using, also you can order a tailor-made material. Fatigue resistance, as we discussed, yes, it has got good fatigue resistance to withstand repeated loading, and that impact and repeated loading that can be really handled with CFRP. See, see the basic fiber material, the very purpose and very property is like having an integrity among fibers. So that will really serve the fatigue resistance. That's what it is. Yes, this is one aspect. Actually, this is a structural aspect of the fiber that we are not aware of so much. But the strength and stiffness of the CFRP can be tailored by varying the orientation of each individual fiber also. So that's a really fantastic. Like even orientation and arrangement of the fibers can also impart more strength. So that is the manufacturer's part of, but it has got that advantages with it. And low thermal conductivity, which we already discussed, this has a good advantage. And applications we have already seen, like aerospace and automotive. So obviously fuel economy, fuel efficiency would always be there. And the same thing, like I don't want to just repeat, but here using, but so far in our department we have not dared to use, but at times, see, now we are in fact thinking to, after Gadkari ji, central minister of, he has promoted to use fiber reinforced concrete. Then even our government is also looking into that matter, whether we can use this. What are the pros and cons with the material, and let us analyze this. Actually, we are doing some work on this. I'll just explain you later. And as due to lightweight property, in sport equipment you can use, and in other industries as per their requirement, like pressure vessels and turbine blades. Yes, see, like turbine blade, obviously with your nozzle force, with the pressure, it would be rotating, and if it really less weight, and that really imports it, it's how the purpose there. Yes. So aramid, it's a kind of organic fiber, which is generally used for fiber reinforcement. So aramid fiber reinforced polymers are the composite material made of, and this is embedded into resins with this organic fibers into polymer matrix, and then that would be casted for structural material. As a structural material, it will be used. Okay. The same thing, like lightweight nature and its tensile strength, good tensile strength and all. This Kevlar is a kind of this an aramid fiber, which is generally popular and which should be used. And this is it has good heat resistance and lightweight and low thermal expansion. Or see here, they are synthesized, then and is spun into fibers. Like different polymers that brought together, and they will be synthesized and then spun into fibers. That's how this are made fibers that will be made of. And also it depends on the matrix selection, what kind of matrix, and that composite would give import strength. And lamination and curing, yes, it's a process. Here what the procedure they use for manufacture would give durable composite. That's they're explaining, which is manufacturing part. And this is also to reinforce structures in the retrofitting existing structures. It has been used, and for strength and durability part. And again, in the defense and in aerospace and in other applications, it has been used. Okay. See, hybrid. See, we actually, when it has come to our desk and when we discussed, like, see, initially let us use as a hybrid. No, it is not the of different composites of fibers, but what we thought is, can we really use with steel? So to have confidence, can we hybrid like that we discussed, but that was not there. But this is a hybrid composites when they're mixed together, and one or two or more different types of materials with different fibers and different no, I think to achieve a specific a property in a single reinforcement. So essentially leverage in the benefits of different properties of the materials, mechanical properties of that material. Okay. Yes. This is how it looks like. See, different fibers are used as a hybrid composite. So different laminates, multi-layer laminates, when they're brought together to have our fiber reinforced component. Again, the tailored properties we see further tailored. You see, when we have different materials come together, obviously you can really, that hybridization we would definitely allow to create different composites of your specific or optimized properties. That's a research part, and that's imparting that. And improved improved performances are observed with hybrid composites. It was written in few research papers, and it's good. And now that versatility would be there with this hybrid nature of fibers and all. And then applications, again the same applications, even in medical, some few dental restorations also it can be used, and all other aspects which we have already discussed. Yes, this generally this is mostly used composite. Generally steel fiber, generally in our concrete we have been using this steel fiber reinforced concrete. Generally in graniting we have been using this. In shotcrete it really imparts good strength, because there is every possibility generally for our irrigation structures, for water retaining structures. We graniting, if you do, we cannot do for higher thicknesses. So for which we look into the integrity of the material there. So where steel fibers or any other fibers would really impart good strength to the graniting thickness. That reinforced concrete thickness really will be intact. It will be so integrated when we use this. So this part I will explain you, like how we have used, but generally we are just mixing in our concrete and we have been using that. Will where we practically used that I will explain. And then rebar, generally these small rebars, like that will be mixed in our concrete and that will be used. That's how we have been using this. That's really imparting good strength of concrete. to synthetic fibers, fiber reinforced concrete. Like, I mean, this synthetic material is also can be used as fiber to impart strength. Yes. When it comes to design considerations, these are the aspects that we have to look into. Fiber orientation. See, that is basically creating that strength. So these aspects we have to, I mean, study a little when we use fiber orientation, and of course the loading conditions should be read, and the Tyler made specifications we can order for, and environmental exposures, like, I mean, humidity, temperature, as we discussed, we can think. Also UV, I mean, even UV environment also it can be used. It's explained.
Incoming voice call from SE Morgan Pat.
Excuse me, it's an official call that being placed. Hello, sir. Good evening, sir. 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 Okay, sir. Vyamavaram కదా సార్? I'll go through, sir. నేను చూస్తాను సార్ ఒకసారి. Vyamavaram I think మనమే చూడాలి సార్. LE అంటే వీళ్ళు మన స్పెషల్ కలెక్టర్ కి we can inform, sir. ఓకే, నేను ఇన్ఫార్మ్ చేస్తాను సార్. ఓకే. I beg your pardon. Like, just I have to inform. It's a little urgent, so గుడ్ ఈవినింగ్ అండి. అది వేమవరంది ఏదో LAది ఒక కోర్ట్ కేసు ఉంది, రేపు మార్నింగ్ హియరింగ్ అంట. మీరు వాళ్ళు అది స్పెషల్ కలెక్టర్కి ఒకసారి ఇన్ఫార్మ్ చేయండి. వాళ్ళు అసలు ఏంటి టేకప్ చేస్తున్నారా ఏంటి, ఒకసారి వాళ్ళని అప్డేట్ చేయండి. ఓకే, నేను కొంచెం క్లాస్లో ఉన్నాను. అలాగే ఒకసారి ఇన్ఫార్మ్ చేయండి. ఎస్సీ గారు ఇప్పుడే జస్ట్ ఇన్ఫార్మ్ చేశారు.
Sir, please unmute your microphone. No, sir, your screen is
Oh,
visible.
yes.
Yes.
I'm sorry. Okay. Are you able to
Yes,
hear
sir.
me?
Yes,
Okay,
yes.
fine. Right. Okay, fine. And then, okay. What are generally these are the limitations. Generally, when we see these are the aspects which we have to seriously look into when we try to adopt a new technology, and the high material cost. This is the prime factor which drags us not to go for. But with the advantages, okay, let us. We also even studying that aspect. And what is the advantage in the long run, and other aspects also we are in fact studying thoroughly, preparing the data and So in our department. So complex repair methods. Yes. See, we encountered a problem. In fact, we are agencies, they have come forward with a glass glass fiber reinforced pipes. Pipes they want to introduce into the department. So we have almost approved, and we also introduced, but repair work is a big problem. So once if it got damaged, especially in respect of pipes, we cannot repair. So it's a huge, very big problem. You have to literally replace a pipe. That's how it would be. And also connection problems and all we encountered, and we could not really go forward with this procurement. So that is only with pipes, but with other aspects we are happy with. In fact, I'll just explain what we have, where we have adopted this. And quality control, yes. See, inside the material, if something happens, we cannot really, this quality control aspect is very serious for us. There will be a wing which would be looking after this quality control. So there are, guidelines are not framed. So and also during manufacture, what kind of material internally it has been used and what is the process. So that aspect government of India, should ensure us to go ahead with this. So that kind of issues are there. And recyclability, obviously, okay, for a certain this thing it won't be there. That is very disadvantage with this material. And high material cost. So my goodness. Okay. FRC or yes, these are like structural strength. It is importing with superior performance, and understanding the properties, their properties and processing applications is a key to the leveraging their potential. Yes, in our present engineering. So this is basically now what I want to just discuss about. Now I'll discuss where we have used this used material and how we can overcome this. Okay, before that I want to just discuss, like see, generally we have used this in our project. One GNSS project is there. There we have extensively used this FRC for ganiting. See, when ganiting, generally we do with general accelerators and with general plasticizers and all. But so there the problem is, see, generally in canal lining, when we do, just let me explain about how we take up the canal in normal process. Generally we excavate canals when soils are there. There is no problem, like general lining would be done. But in case if the strata is a little rocky, let us say F&F or fissured rocks are present in the cross section of canals, then lining would be a problem, because we cannot cut with uniform slope. There the problem is, like we have to make up the sides with certain material. So there our material usage would be more to cover the undulations on sides. Generally, as you know, I'll just show you a this is actually an approved drawing for our ganiting. Let me just explain this. See, here, when a canal section is like this, when it is cut for our, it will be generally, I mean, we excavate canals for kilometers together. Here, generally what we do is, when the soils are present, we go for lining. As you all know, to reduce the section, to increase the hydraulic efficiency, we go for lining. So if it is normally excavated, if it is taken through our canals, your I mean N value or rugosity coefficient will be more and your hydraulic efficiency will be less there. But to improve our hydraulic efficiency, what we generally do is we recommend lining for the canals. So with the lining, what happens is, like, I mean, our discharge would obviously be more there. So here, generally with normal soils, the excavation would be very easy. But in case of a rock, like, I mean, rock stretches, I mean, if the strata is rock, like F&F and FR, all like hard rocks, in that, I mean, there would be more undulations. And here, we cannot cover this portion. It will be with lot of undulations. Then all that has to be filled. Suppose generally what we do is, generally for canals, we recommend 100 mm thickness lining for the entire stretch. I mean, depending on, of course, the soils. But there, what happens is, if these undulations are there, to fill up the undulations, you have to, there will be more material that will be used for undulations itself. Then what we generally do is, like, I mean, at times we go for ganiting. So with the ganiting, what happens is, like, that protrusions will be like that, but the smoothening of section can be taken up with your ganiting process. Also, we leave the undulations like that and we go for lining in those particular stretches. So with this, what happens is, we achieve our coefficient and that flow would be there. And then also the filling up of these undulations can be avoided. So this is where at times we recommend ganiting in place of lining. So only I'm telling you, only when a rocky strata is there. So here, when we go for instead of ganiting, so in the ganiting generally, I mean, when we for the water retaining structures, when we do ganiting, the problem is, if at any place, if it is disintegrated, once the water enter into that spot, and that will damage the entire lining. So this is a very serious factor for us. So we cannot assure in F&F areas, like there could be, I mean, shear zones, and you cannot really, I mean, ensure a proper bond, rather proper closing of the entire portion. So in which we need integrity of the layer. So the proper integrity of the layer is very much required there for us. So for which we require some kind of material that should be give some adhesive property. Like, I mean, that integrity between the material. See, obviously our concrete is more heterogeneous. I mean, with which there is every possibility that, I mean, there could be seepage due to your either due to with your honeycombs, or like, I mean, with your improper mixer of your mixer and all. With all this, there is problem of binding to get that binding. So here you can really, I mean, overcome that problem with your FRC. Is it not? See, the FRC, once if it is mixed with my this thing, and if this ganiting can be done, so it really imparts good strength, since that I mean, material integrity would increase, and obviously there is every possibility to avoid seepage into the soils and escape of soil particles and damage of the entire lining, which is a very serious problem in our department. So this can really overcome with this use of FRC. And in GNSS, for the first time, we have used this mixture of FRC in that. In our concrete, in our graniting, generally what we use, just generally our cement, sand, and water. With that, with pressurized grouting would be done. But also, generally, whenever we go for lining, we go for steel mesh. We also avoided that steel mesh since we have enough strength, which we would get using this matrix and fibers together. Okay, in this. So that is where we are using. This is basically where we are into your this topic. In fact, we got introduced to this. This is where we have been using. After that, even in HNSS, in one lining, we have adopted this. See, one more thing. Here, generally, thickness can also be reduced when we use this. See, generally, what we do is when we introduce mesh, we take a little more thickness. Taking that also into consideration. But using fibers in our concrete can really reduce this. This is really an effective thing where we have been using fibers in our concrete, duly reducing the thickness. But this aspect is more for discussion. So whether to really reduce the thicknesses using this, but it's for discussion on our tables. Like now we have been discussing whether we go for less thicknesses, since code specifies certain thickness for different kinds of stratas. So now we have to rethink, and government should really come forward with less thicknesses proposed for with using fibers. That is for discussion now, and we have to also have to impart in the discussion, and then can use in the department, because it is a huge volume that we use. So this has to be with a policy, it has to be introduced in the department for make use for the entire in the entire department. Okay. Okay. See, can we have a, if you have, see, it's for a discussion. Like if you pose any questions, I'll try to discuss on that. Okay, Achanaji, like you just convey from your side, like if any issues are there. In the next session I have the other topic to explain, but for now I'm just conclude with this. Hello. Hello. Are you able to hear me?
Yes, sir.
Okay. So Okay, one more thing. As I said, wrapping of for the structures for like columns, like piers and all, it will be more advantageous, I feel. I mean, from my side, what I can really throw is like since jacketing is a very a serious aspect when retrofitting is done for the existing damaged portion. So I felt like, I mean, with the experience I have with FRCs, like, I mean, wrapping up the existing structures, that retrofitting is most feasible with FRCs. Sirs, like, I mean, if anybody is I mean, part of this, can also, I mean, advise me. But I feel like wrapping and jacketing to the existing structures using FRC is more advisable. We have done the in the traditional way, like having certain thickness around the existing structure, duly sort of forming certain mesh over it, and we have been covering with the certain thickness of concrete with our experience. There, in fact, we are not doing any design things, but what we are doing is like only stability aspect we have been checking, and we are introducing jacketing to the existing structures. But when the same thing could achieve using FRC, that will be more helpful, because with less thickness, like using resins and fibers with less thickness, I think we can achieve that and make the structure intact. That is really a point for discussion. Like we can have that kind of retrofitting using FRCs. That is most important. Here, when we used, like, I mean, we have used silica. Silica with fibers, with, I mean, glass reinforced, steel reinforced fibers that we have used in our ganiting. Then ganiting process, when we have done, it is most effective. What we have observed so far, like, I mean, it's more effective. Even the surface, when we observed using this, is intact. And with the field people, when we interacted with them, with their experience, what they have expressed is like it is in when compared to the normal ganiting. So in the normal ganiting, there is a possibility of disintegrity in the surface when it is observed. One of the person who has really helped me out in obtaining material from the field, what they expressed is like it's in fact intact when we do the lining with FRC rather than a normal ganiting. So as we all know, ganiting is a process where we I mean, shotcreting we do with normal plasticizers and accelerators. When it is combined with fibers, it's really good. I mean, with silica and fibers. See, generally when we adopt a new material, what we do is first we analyze. See, we have to get approval, administrative approval. Though the technical aspects are with us, obviously, I mean, fiscal matters we have to deal with our government. I mean, finance departments. So we have to prepare, I mean, the rate analysis, which should not be any audit problems, without any audit problems, for which we have to justify what we are doing. I mean, when compared to the traditional way of working. So there, when we observe, like we have mixed, I mean, 50 kgs. See, this is only with the guidance of the people which they have already done. I mean, in few agencies they have already done, but from the companies which are supplying these fibers have suggested, I mean, per kg, per bag of cements, they have 50 kgs per cubic meter we have used. I want to just, I mean, put forth before you, like this is how much we have used for each single bag. So it is, I mean, cost, it is definitely expensive for us, but the strength that we are obtaining is good. And also we felt that I mean, it would be long lasting, and that would serve the purpose. But also we had a lot of discussion during our adoption, but there was no time, and we have gone with steel fibers. But since water retaining would be there, we preferred other fibers rather than steel fibers. But we have finally gone for steel fiber reinforced graniting only. But since it has been done recently, we have to see the life of it. But with our visual inspection and even our quality team told that it's more intact and very robust when compared to the normal graniting. Okay. Okay, then see, I want to just share my experience in Pulchintala. You might have already heard about this project, which was national news once when the gate was washed away. I want to experience my projects. An event which unfortunately occurred during that time I was not there. Later I have transferred to that project as an executive engineer. But but as a mechanical a quality wing, I have attended that project. But how it has happened is a radial gate was washed away, almost 17.5 meters by 18 meters. Gate was literally washed away from its location. You believe it or not, such a huge gate was literally washed away from its location. So it was my project is 24 gates project. It is almost half of the Polavaram project. Almost the same size of gate that is there. It is on Krishna River, on upstream side of our Prakasham barrage and downstream side of Nagarjuna Sagar project. Hope you, most of the people well aware of that. And see, why I am just discussing that, what is the, why I am discussing is because, like, when it got, washed away, the problem we encountered is like the strength of the pier. Mostly that could be, and most of the in the preliminary report, so there are a number of reasons. There could be because of loss of our gate there, but mostly what we observed in respect of concrete is like there are weak points. It was also tested, and it found that there are considerable honeycombs and weakness around the embedded parts of the gate. So generally a trunnion part would be near the pier, where the tie flats will be embedded into our pier and from the gate. So in that portion, what we have done is we have strengthened with some micro concrete. So it is not basically a Farsi, but resins we have used. A part of this resins, some Conbaxtra, fast rock material Conbaxtra, you might have heard about EP Conbaxtra EP10. We have used it for grouting into the pier, to strengthen the pier around the embedded parts. Like all the anchor rods have got replaced in that project. So literally, pardon? Hello, pardon? Okay, right. So there we have used this and we have grouted the same into the pier. So that's what we could, how we could achieve the strength. So again, we have tested and we got enough strength in that. That is one aspect. Also, few parts need to be filled. Actually, that project has some issues. Like the few parts need to be refilled with concrete. There we have used micro concrete. So micro concrete, like micro silica with certain resins have been used. So we have filled up all the area with micro concrete, and convex by EP10 grouting we have done for the all around the embedded portion. So this is how we could really overcome the problem that we have encountered in the PR. So that is one incident where we could really retrofit the piers by using resins and all, the epoxy resins. So through epoxy, like Canvax Tri is a with a base and this thing Convax Tri EP10 we have used, and it's really worked good. That's what I really want to share my experience in the project before you.
Thank you, sir. Thank you so much for your valuable time and enlightening session. Here, I request our participants, uh, please be interactive, and if you have any kind of questions and doubt, they can put forward. Please unmute yourself and put your questions.
Dear participants, like due to my time constraint, due to with some exigencies, I could not make much more than this. I really thought of doing good things, but we can really discuss on any aspect. Generally, I worked in the designs wing in the irrigation department for quite some time, and I got a good design experience, and I really welcome any kind of questions in designs in department, particularly in irrigation structures. Like also, regarding this matter, if in the point of discussion, we can discuss.
Here, Mr. Saswat Sarna has a question here. The question is from a life cycle sustainability perspective, does FRC reduce maintenance cost and extend service life compared to conventional concrete?
It's the voice. It's not a little clear. Please.
Saswat sir, you can unmute your phone.
Repeat. Okay, it's all right. I mean, you just repeat the question.
Yes, sir. From a life cycle sustainability perspective, does FRC reduce maintenance cost and extend service life compared to conventional concrete?
Yes. See, I just answer from my, I mean, with my components. Like, see, suppose in coastal areas there is we encountered lot of problems. Like, I mean, the spalling of uh, I mean, in the structures, a spalling problem would be there, because I mean, if there is any honeycomb and all, due to humidity and all, there is every possibility that water will penetrate into that, and once if this oxidation on our I mean metal part, it starts, obviously there would be spalling, and we have to literally, either we have to go for retrofitting, and at times we also need to replace the structure. So obviously, I mean, in lifetime, that we can, I mean, using these kind of material would definitely sustain for long, and that's really a good thing from this side. So that can really overcome in the long term. Definitely, that would be advantageous, rather than replacing or I mean retrofitting with no issues. This would sustain. So we can really, I mean, welcome this material for use in such areas. Not all, definitely. Suppose if you want me to really use somewhere else, I definitely think twice before I go for that. But at places where there is vulnerability, see, obviously all our irrigation structures, we are we have been using sometimes epoxy or with coat we are using, but this would definitely give better performance. So with that, we can really recommend. Yes.
Thank you, sir.
Yes. Right. Shall we go with the other? Let me break. I mean, would you take some break, or like shall I go with I mean the other topic? So that actually I
Dear participants, there is a small announcement here. Actually, our next resource person is the same person of the first session, I mean the previous session. So he needed a small break of 5 minutes. So on that period, uh, I want to clear that QR code what we have given here. Please, many of the participants are not filling that form. So kindly fill that feedback form as well as the attendance form also. The feedback is day wise, whereas the attendance is for the session. So per day you have to fill for the attendance purpose two link or two form, and for the feedback purpose one form. Already it has given in the group. If you say again, we can share in the chat also. Okay, madam. We are doing that. Jyotirmay. Here, Hemant sir has put one question. We can ask this question after this end of the second session.
Next. Let's begin now. Next.
Now let us start our next session here. Here I would like to request our resource person, Mr. Gunakar sir. Please sir. Sir, you can share your screen, sir, here.
Yes, right.
Sir.
Incoming voice call from Aruna EE 742.
Okay. See, okay. Now I want to discuss on glass fiber reinforced polymer rebars. See, this has come to our department as we are just planning, and somebody has recommended this to department, and we are just thinking and how to go about. Like we also, checking the sustainability, and departmentally, officially, it has been taken up, but not still extensive work has been done. Otherwise, I would have really come with good, points. But later, if there is any chance, like I would definitely discuss. But for now, all this has come to our department. How this can be taken up, like structurally, how we have to design using GFRP rebars. Okay. Generally, glass fiber reinforced polymer bars. These can really be replaced with steel bars, because we'll now discuss the strengths, how they are imparting when bars are GFRP bars are used. Like these bars are built with different like raw materials, like glass, carbon armament, as we discussed, of course, basalt fiber and all, and with epoxy resins or vinyl resins and all. And the process of is followed by pultrusion, as I explained, like this pull extrusion. Pull extrusion means pulling with force, like we generally extract these bars. So we call it, the process of manufacturing these bars are called as pultrusion process, where we'll see, through a representative, you appreciate like how the process would be done. That I will explain you a little later, and why. Yes, why it is alternative for steel, which the same properties that we have already discussed. Corrosion for steel would definitely, a point where you can go for, and chloride rich, and improving durability. Durability of concrete structures important, because in civil applications, mainly because this corrosive aspect. Now, non-corrosive aspect. So that we have to bear in mind really when we go for this. So this is how the status of coastal regions would be when it is exposed to atmosphere, and if there is any kind of distraction in the structure component, it would be like this. So for which we require certain thinking whether to go for a steel reinforcement in coastal areas, and where it will be continuously exposed to water. Okay. Here we will go a little into technical details. Here, see, corrosion resistance, one point. If you keep in the lifespan, how we can really go for. And here by weight, generally with certain composites, we have 1/4 of the weight of steel. for the same steel, now it is 2 times the tensile strength it's imparting. Almost the 2 times the tensile strength of the steel we can achieve. So if that bar is really replaced, I mean, this is more advantageous. Okay, with other parts we have to look into that we'll discuss a little later. And then, of course, non-conductive nature through electricity, as of course, as well as heat. That advantage, resistance chloride, and cost effective. See, cost effective, you see that aspect, as we discussed, like it is not cost effective sometimes, but your usage that you have to look into. And yes, can be manufactured in custom lengths. See, as we discussed with the manufacturers, he said, I mean, any kind of length based on the placing of order, he can supply in no time, because the pultrusion process is easy, that they said, and we can see with urgency, exigency is also we can really, I mean, supply things, they said. And also bends and shapes with certain ductility, they can go, but you cannot just bend like how we do for normal steel reinforcement, but you also can do that bends and shapes that you can arrive at. And suppose our stirrups are there, you can place the order for stirrups and you can directly get it. Any kind of shape as such can be obtained from the manufacturer that is there. And okay, obviously easy to cut, yes. Sometimes, I mean, machining, generally our mechanical parts, like I mean rope drums and most of the materials we require machining. So machining, generally we use lathe machines and all for machining, but for obviously it is very easy for the GFRP material. So that machining can be easily done with this. So that is one most advantage with this. And other grooves and also threading and then shaping into our required sizes and shapes can also be done. Okay. And then obviously maintenance free, since there won't be any rusting and spalling and all won't be there, and you can really achieve that maintenance free with usage of this. So lightweight, your labor cost and all would be reduced, and we discussed. And of course, it's definitely a green product, and compared to steel, see, it's a robust process, and where environmental issues with it, this is definitely a green product we can say when compared to your steel. Yes. So any concrete member affected. Okay. So generally bridge decks, see, they expressed that they have done not in India but in abroad, like they have taken up large bridge decks were constructed, even sea walls were constructed using GFRP, and I have brought those I mean designs to our desk, and now we are checking. So that will put forth what action that we have to take on this, and what the other problems that we encounter when we use this. And yes, here what they are saying is, I mean, because of its non-conductive nature, like in MRI rooms and all, non-magnetic nature of the glass fiber reinforced, like they can also be used in MRI rooms and all. So while constructing MRI rooms by us, we can really go for this. This is where we can use GFRP in place of steel reinforced structures, steel reinforced. And other more applications are like architecturally, because any shape you can order. So with that, you can have architectural precast you can achieve. That is one advantage with this. Of course, in swimming pools and all, where all complete water retaining would be there, can be used. So see here, the galvanized, I mean, steel, it will be alternative to epoxy steel, or I mean galvanized steel, and the stainless steel. See, generally you cannot really, I mean, say that it can directly replace the steel bars, but wherever it's steel, I mean stainless steel is required. Let us say, suppose for our gates, most of the gates we go for, I mean, stainless steel gates, near the coastal region. Suppose if outfall regulator is there, when an outfall regulator is designed, obviously it will be in contact with the seawater. Generally, what we do is at the end of in the tail end canal, we let the water into sea. So where there is at high tide, there is every possibility that the water would be the seawater would be in contact with our gates at the end point, where we let the water into rivers. We encountered these problems at our canals. There, I mean, usage of in place of stainless steel, definitely this can compete. Like glass fiber reinforced gates can be replaced the stainless steel gates. They also assured that they would do it and erect the gates in place of stainless steel gates. We have been using stainless steel, complete stainless steel gates there, because I mean there would be perennial problem that because of seawater our gates would be spoiled because of rusting and all, where we can really make use of this GFRP gates in place of normal stainless steel this thing. Okay, now more technically, when we compare, like I mean for the bars, it has been prepared through GFRP. It is almost, see, you can see the tensile strength is 360 to 400 for our steel bar. Let us say, I mean, for FE5 up to FE500, you see, like it is almost the equivalent one would be 800 to 1000 for the bar. See, you just imagine a steel bar like this, or like I mean, which is literally replacing our steel bar, could really attain a strength of almost double. You can see almost double the tensile strength it got. So the each steel bar, it can really replaced once if this is confirmed, like I mean, is more advantageous. So the structure size would definitely be reduced, and the volume of the construction material would come down, and obviously your weight of the material would come down, and this would really, I mean, a luring point where you can go for a GFRP bar in place of steel bar. But the other aspects should be looked into. Like I mean, can we in concrete, can we go for the can we directly replace that on which we are really working with. And see, elastic modulus is like, I mean, obviously GFRP will be less, and tensile strain will obviously be less. So with that, and of course, when it is shear strength, it's all equally good. See, 130 for I mean steel rebar, and it is almost for our GFRP it is 160. So density would obviously be less, like 1.9 to 2.6 when compared to our steel. So since specific gravity is like I mean in thousands it is, and then when compressive strength, when we talk about, it is more or less same. Like I mean for this particular I mean composite, like I mean it would be different. So as per our requirement, of course we can order for it, I mean to improve that with their composition of materials there. And when it comes to bond strength, almost same. You can see this, and thermal coefficient, it will come down. So to that extent we can really see this is again hand in hand they can do. See, with the material they are using, in this case it is around 9 to 12, and corrosion resistance obviously excellent, and then chemical resistance is there. Thermal conductivity obviously won't be there, and electric and magnetic, electromagnetic, all this is the basic advantage now so far what we discussed about. And then life expectancy, they say, I mean like sometimes infinity, but until like more than 100 years they're assuring. But of course this aspect we have to really, I mean, look into, unless until we got the that experience we cannot make out, but with the mechanical properties, they could assure that it would be more than 100 years. And see what they are suggesting. Some certain agencies, they are suggesting like it can be replaced like this. For a 12 mm bar, it can be replaced with 10 mm bar. So this is what their contention is like. I mean, since obviously in respect of tensile strength, if you see having the other mechanical properties intact on par with this, but see that advantage we have to see. See, technically when we do designs, like the other parts, if they are not, that is considerably increased, what is the advantage of using this material? Suppose let us say that your tensile strength has been increased to double, but sometimes in the meantime, if it fails by your shear or so, which is almost equivalent, and if your compressive strength, if it is almost equivalent, can I use this bar? That is my basic question. So that we have to see. It would again be with respect to your design and with respect to your structural component and its technical requirement. Depending on that, you can really adopt this kind of structure. Am I clear in this aspect? So that is my concern when we are trying to adopt this structure. So as a whole, for the entire construction field, it can never be adopted, I think. So obviously you have to see for that particular requirement whether this can be adopted. Okay, that is my concern. That's what on which we are really working with. So I think we get with good information if that exploration is completed. And also, like the equivalent bar, they are suggesting something like for 12 mm it is 10, and for 8 mm like 6 mm bars, and then 10 like 8 mm. So that is equivalent area. I think he might be comparing. Okay. This is what they are showing. In fact, they are showing what the gain in your weight. What they are claiming is like you are seeing with respect to weight, but once if the design is done and if the exact material, the same equivalent material, if you just work out, it would considerably be reduced their confronting. So let us check this aspect from department side, and then we'll confirm. See, once if any department, if it once confirm and give a green signal from the government side, then it can really be adopted without any objections from the users. This you can compare here. The permissible load bearing capacity is they're saying 2.5, and compared to, and the permissible, here in the steel bar you can see this. You can compare, almost double they're showing. Okay, load bearing capacity. But this aspect, literally, as we go through the design aspect, we cannot make out. That is in the process, and we'll get back with those details. And they are saying they have been using in all the aspects, though IS codes are not there, but there are a number of codes which are available internationally. So based on that, they are asking us to verify, and they are planning to introduce in BIS. In ACA it's there, and ASSUO like that. And see also, each individual codes are available for a bridge design guide. Guide specifications. It is there. Which we are now concentrating on, and also on the retaining walls. Especially these are the basic structures where we, literally go for water retaining. Like all low level causeways we go for water retaining, which are need to be designed with other than rusting material rather. So So these are some structures would they have already executed, certain companies. So they have shown all these bridge panels construction using GFRP. So these designs have been for us in the recent past, and we have to now look into this from departmental side. This is the a shore wall, retaining wall, which was constructed near the shore and in the coastal areas. And for industrial flooring, like where chemical exposures and all are there, they have used this. And they said even for drainage arches also they have been using GFRP, and water treatment plants and seawall canals and all, and even for toll plazas they used. This is the basic exposure that they have given to us. To adopt the these materials in the day-to-day life, showing their sustainability. Let us check and assure this. And this is the basic process. How it will be done. Generally, they are saying some creeling will be done, and then it will be condensed, and fibers and all will be creeled, and then the condensation will be done, and then those creels, it will be chemical bath will be done, and then chemical condensation would be done, and then dyes would dye, it will be dyed in dye in size, and then it will be subjected to polymerization in ovens, and of course the cooling for solidification will be done later, and from there your required size can be pulled by puller. Like that's why generally this process is called pultrusion, thus pulling by puller, and then for the required lengths it can be cut, and this is how. And coils also can be done. See, like initially I thought, can it be this flexible? Yes. So you can see this, the vase could be wound up like this, and coils can be formed, and that can be placed. At initial stages, and when GFRP was introduced, and how this could be done. But yes, with its property, it could be done in these forms, and can be used in fields. And also like this, even your stirrups and all can be ordered, and you can get directly from the manufacturing unit. That's what they are telling. Unit anywhere they can install, and they can supply material. That's what their assurance is for us to make them use. So what obviously there will be a disadvantages, and we have to look for a way out there, and because of its low ductility in nature, additional calculations, yes, that's our concern now, and we have to see and what could be the repercussion because of this low ductility aspect. So the combination with steel can give dual advantage to strength and ductility. They are also assuring that, but this is design. Again, design is a problem. See, completely their mechanical properties are different when they are combined with steel. Like how the design would be, like how in hand in hand it should be done now. So that's what we are thinking today. Like how we can achieve in combination. In the event of additional structures, concrete cover, yes, that concrete cover can protect and the rebar and improve the stability of the structure. That is one disadvantage. See, fire measures and all, so that a cover requirement we have to find out, and that is only with experience. That is with our concern. Like if it is introduced, and if anything untoward occurs, what would be the case? And GFRP can be used for combination with steel vents. Yes. So when we asked how to, for all the beams for different sizes, how it can be achieved, it is said that steel vents can be for the beams and all. And then shapes of the stirrups can be ordered. And the precise measurements we have to see, because I mean to place our this thing to maintain the exact cover, we require only at site we can decide. But here, I mean, beforehand you have to decide and place order for supply. That problem is there. And this is where I mean we now at this juncture we have been thinking to go for this, because Mr. Honorable Minister has recommended and of course promoted this GFRP parts to use in roads and highways construction application as per notification. Initially, we also thinking to use that approach roads and all. So where you can really go for without any since the I mean design aspect is not that considerable there. Okay, so this is all about my this GFRP bars, and see if there is any I mean topic to be discussed, like I mean please pose questions so that we can discuss in detail. What are the I mean questions that are raised? Archana ji?
Yes, sir.
Can you make it like I mean to have a so you said some I mean some questions on this. Can you just show that to discuss on it?
Yes, sir.
Is this
Actually,
how to make it out, please?
sir, here Hemant sir, he has asked a question. Can
Yes.
geopolymer concrete can be one kind of self-healing concrete? That means, can we have self-healing geopolymer concrete? Healing.
Please
Self-healing geopolymer concrete.
Self-healing.
Can geopolymer concrete can be one kind of self-healing concrete?
Self-healing. I didn't get that. Okay. I mean, your question is like, I mean, see what their basic explanation for introduction of GRPF is like, I mean, that problem doesn't arise. Okay, that self-healing may not be required. Like, I don't know. Like, I mean, would that be answer for that question?
Sir.
And what the other one is like? But okay, I mean when just for discussion, but self-healing, see, as a matter of fact, any material that you use, it depends on the quality of the construction execution. It depends on because see, like if the construction is intact, there won't be any problem, as he said. But if there is I mean construction difficulties, but as such in the GFRP, I mean when reinforced fibers, that problem can really reduce. You can get reduced, because basically the concrete is a heterogeneous material, so you have to properly maintain the water cement ratio and all other aspects like mixing, maintaining workability, and that consistency. You have to maintain all that. But when it comes to GFRP, as you said, like I mean, there is a little possibility to overcome that, because I mean it'll be taken into it, and to some extent that can be taken care. So I think I could convince you, I mean, with my explanation, but I cannot say anything more than this.
Sir,
Okay.
thank you, sir.
What's
Sir, we
the
have
other
one
one?
more. Yes, one more question here. How FRC help make building more sustainable?
That's what. See, like I mean, see in the buildings, in the in the earthquake aspect. See, when we use this, we are of course taking care. But when in the earthquake zones, I feel, I mean, usage of fiber reinforced is more sustainable, I can say, because see, this can definitely, I mean, take care of that. This I said, technically, I mean, we cannot answer like you theoretical people, like, I mean, academicians should answer this. But as a practical man, I think definitely in seismic zones, in the retrofitting zones, I mean, this is definitely more sustainable. And as a material, as the property of mechanical properties, property of the material, when we look into that, I mean, that integrity would be more when compared to our I mean, heterogeneous material of I mean, concrete. That's what I can say from my side. So I think, I mean, some academicians should answer on this, but from my side, I can justify it only to this extent. Yes. Is there any more, Archana ji?
Yes, sir. Yes, sir. One more question here. What are the advantages of FRC compared to traditional material?
That's what. See, but not everywhere. That's what I said. See, definitely not everywhere. See, you cannot. Recommend this for non in the everywhere where we are using traditionally, but at places where there is in coastal regions and all, definitely that will be advantageous, since it is non-corrosive, where I mean the deterioration of concrete won't be there due to oxidation and all. That rusting part you can take care using this. Yes.
Yes, sir. Sir, can natural fibers be reused after its lifetime process?
It depends on, yes. See, in one of the papers I read, yes. See, it is sometimes difficult. See, it depends on the matrix that are using. See, sometimes you can retrieve that, but not every time. So it depends on the matrix that are using, whether it can be reused, but partially yes. Yes, this question. See, I have my own doubt. Is it durability compared to traditional material? Definitely, I mean, this aspect we have to look into. See, we have not encountered any catastrophic failures, I mean, for the constructible structures, unless until definitely, see, from the mechanical properties wise, yes, they are durable, but practically, when we encounter a few things, then the analysis on that would definitely give us it's a durability factor to us. But as of now, yes, it can compete. Yes. Shahani ji, yes, you have used a good word, cost efficient. Yes, it's a big word. Actually, yes. When I said, see, only to some extent, this you asked like, is the use of GFRP cost efficient in construction of residential buildings? In the residential buildings, again, again the answer for this is like, I mean, in coastal regions. See, I'm basically from Vizag, so there the construction would be taken up almost at the seashore itself, I have observed, lot of deterioration in my, lifetime. Like, I have seen lot of buildings and they got rusted and deteriorated like anything. For this, you can say it is cost efficient in that respect in case of residential buildings. Yes, but not everywhere. That you cannot say for all the this thing. Even they are not, see, a company which approached us could give only to a G+4, not for tall buildings. So based on that, we cannot assure for other all other residential buildings. Okay. Okay, see, like the other things are like, see, one aspect I want to just discuss with you. See, which we have to in detail see is like rate analysis when we prepare for GFRP. Now, we could not really make out. See, since steel, it has been established for certain time. Even Government of India from Metal Mart and all, they could give what is the cost of the steel. So thereby we could give the escalations and all. We are applying for our cost analysis. But in cost analysis, when we do for a new product, so we have to see what is the labor it require, the machinery it require, and then and the material they are using, what is at what cost we are getting the material, and the government could supply material to that companies, how they are costing, including our taxes, all that. So unless that is finalized, it is very difficult to assess the cost. So we people can bank on only rate analysis that has been established with the guidelines that we have to prepare the rate analysis for a new component. So here, when it is introduced, I have to see what all machinery it require. Of course, apart from manufactured cost, I am telling about. During the execution, I have to look into the matters like, what is the machinery that would be required during execution, then compared to the traditional material that we have been using. And then the other parts are like, labor that it requires. Suppose, for steel bars, when they are carrying, it is hazardous. We cannot just handle with hands. Because, grass reinforcement, there is a tendency that, its skin allergy would be there. So there, and certain materials would be required, like, gloves, and maybe other parts, I don't know, like, environmentally, what care need to be taken at that area and all. So likewise, so we have to assess all components, how it has to be looked into. So that is the very important part we have to go through. Yes, that is one part. I want to really explain to you like how to analyze or fix up the rates to fix up a standard rate. See, one more issue, as it is lightweight material compared to steel, should this be used for making prefabricated structures? Obviously. See, like definitely that will be that would be helpful. So at the manufacturer unit itself, you can prefabricate structures, components, and you can integrate together at the site. Yes, see. Yes, Aniji, yes. What is like, when steel, definitely this would be better. Okay. So I know very little about this nanomaterial. So actually I have not, due to my constraints, like I could not really make it. See, it's a very interesting topic. I really want to I thought of attending, but due to my personal and official issues, like I could not really attend that program. That session. But I think the hybrid system would definitely be helpful. Yes, with the little knowledge I have, let us discuss in other sessions if I'm there. Like we'll discuss. Yes, I think as you said, nanomaterial. Where the hybrid system would definitely be efficient. Yes. Okay. Okay. Thank you. Thanks a lot. Right. Okay. Achana ji, shall we?
Yes, sir. Participants, if you have any query, can please. Or else we will. Sir, one more question came here.
Oh, yes, sir. Government. Oh, see, for this question, government actually planning for sustainability. It won't be like a policy. See, it has to be. Requirement would only. Bring this. As a policy, it has not been taken up. Only in academics will be. In academicians should approach the government and should tell, because we people, we cannot explore to that extent and recommend the government to do so. But see, we explore as per the requirement. For your question, what I would say is government, whether it is planning to implement these sustainable materials only when the requirement. See, when exigency, see, when in GNSS project we have adopted this only because of exigency over there. Like we have to complete the project. Within a short period. There, what we have done is we have go for gunniting there. So gunniting alone would be a problem. So what best we can do, we thought of, and we discussed with government, and government has taken a step to go ahead with shotcreting with fiber reinforced materials. So that's how we could do it. This is how things would happen in government, as a matter of fact. It's not a proposal from our side. See, for this, I always wish academicians with departmental people should make a policy to the government to adopt and plan for sustainable materials use in the department. Once in the department, it's a huge requirement. So definitely that will be popular and also get confidence by civilians, and it will be useful and it will be used also. Yes, Anaji. Yes. So, yes. Yes. Here, one more question from Aritaji. Okay, here FRP is generally less stiff than steel. So will it be okay to use when limit of serviceability concerns? This is the major concern. So we have to look into this matter. See, like in the limit state, we have to apply, and so enough research need to be done. But as far as the agencies are telling, it would be sustainable in serviceability aspect also. So that we have to see and apply to certain components which are not hazardous, and then we can confirm this. So it is in the process. See, it is too early for me to answer this. But with the information I got through net or whatever from the agencies, yes. What? Yes, testings and standards it has been given, but testings testings they said, I mean, certain testings are there. I mean, NABL labs also available for testing, but obviously the same testings what we are conducting for I mean steel reinforced, the same testings need to be done. With which we got the mechanical properties, all mechanical properties which have been given, I think would be the same testings need to be done. And with respect to durability, I don't know, frankly, I don't know. I can't just answer that. But the other standards with all mechanical properties, I think with the, I mean, same testing, it can be tested.
So here Saswat sir has put one question.
Pardon?
Saswat Sarma. Which sector like bridges, pavements, housing or smart cities will benefit most from fiber composite in the next decades?
Please repeat.
Which sector like bridges, pavements, housing or smart cities will benefit most from fiber composite in the next decade?
Next decade, okay. So if it is next decade, I say, I mean, okay, the same answer. See, obviously, see, like, I mean, in only in the areas of, I mean, like, as I said earlier, like, I mean, where the problem is, see, the very advantageous would obviously, I mean, lead us to use that. So the corrosion factor is the basic factor. And see, the other factors like, I mean, cost effective. See, it must be, if it is cost competitive, cost effective, definitely people would think of it. But only for the purpose, obviously you have to, I mean, invest more to go for that structure. So then only at the problem areas we can adopt this, not the other areas. Suppose, as I said, gunniting. See, gunniting problem, I'm telling you. See, I mean, in the undulations, when the rock strata is cut, and if in the undulations, I mean, placing steel and then doing gunniting is not that easy. So where you can really use, I mean, FRC, so which would impart the same strength. So see, likewise, the purpose is only bringing that for usage, but not cost or any other thing. So only the advantage will only be there. But what for your question, what my, I mean, feeling is like, in grouting aspect, this would be more useful, and this would dictate. And then I cannot say, like, I mean, whether it is bridge sector or, I mean, residential sector or in the infrastructure, where that I'm in that way, I may not be in a position to answer, but I can definitely say where it can impart like, I mean, it's a strength to replace steel, like, as I said, for gunniting, the shotcreting and all. Yes.
Sir, here one more question.
Yes,
what
yes,
are the emerging areas of bacterial concrete combination with geopolymer concrete?
I'm sorry. So this aspect, see, like, I mean, the other areas I'm not that much acquainted with, because see, this only, see, we department people, like, I mean, we come across only when we use in the department. Not, we are not so versatile, and I can really not answer this. Like, our academicians should answer this. Okay, frankly, I don't know. Like, I mean, actually, I heard about the, I mean, bacterial concrete, but in combination, how it would work, no, I'm not in a, I'm not that expert to just answer that. as a practical man. But the other thing is, can you highlight the mechanism by which the fibers improve the performance of concrete? See, here the bond strength. See, generally when resins are added to the fibers, see the strength, the transfer of load. See, binding material not only binds the fiber, but also transfers the load effectively from one fiber to another, and thereby that that load transfer would be more effective. So that's what it imparts. That is basically the particle. See, generally what we do, see, even though it is heterogeneous material, we assume that it is homogeneous, and we say the load transfer would be there from particle to particle, and that's how we are designing also. See, if you take a cross section and if you see the a stress pattern in the cross section, it is not with respect to your material disintegrity, but you are taking it as a homogeneous, and we are thinking that the load transfer and the stress across the cross section would be like that. But here definitely this is more robust. So since resins are it has more integrity rather than our concrete with sand and aggregate and all. So that's the explanation for it from my side. Just let me check. There are good questions. Okay. Oh, what is the role of the matrix in composite material? So that's what now we discussed. No, like that matrix obviously, see. So fiber, it imparts strength and stiffness. Here it is a binding material. Also, the strength of your fiber is basically with your with your matrix only. That epoxy resin, or whatever the polymer that you use. Yes. And what is the other? Are fiber composites suitable for both new construction and retrofitting? Yes. That's what I explained. The wrapping and jacketing can be done. Retrofitting, it's more effective. See, the integrity of a fiber material with the old existing concrete would be more effective than concrete on concrete, old and new concrete. So of course nowadays we have been using some materials like chemicals in between, and we are we could achieve that. But here yes, that itself is a chemical compound which have a adhesive nature to the concrete, and yes, it is definitely suitable. And then, are there any startups and the agencies who are using these materials in India? I heard internationally like very many, but in India, okay, yes. In roads they have been using, it seems like. In certain fibers we have been using, but bars and all, like very few agencies to my knowledge. See, no startup agencies are required for that. The materials you can directly, go, and methodology you have to follow, and you can make use of that in your daily this thing. See, again, you have to find out the composite structures density when it is mixed, at what ratio it should be mixed. So only with the experience, and it has been advised, and we are going with it. Again, we have to see at what ratio it would be more effective. Okay. Yes, Achna ji, like
Yes, sir. I think thank you, sir. On behalf of the organizing team and all the participants, I would like to extend our heartfelt thanks to you, sir, for your valuable contribution to today's session. And your insights, expertise, and engaging delivery made this session both enlightening and inspiring. The way you presented complex idea with clarity has not only enhanced our knowledge, but also encouraged us to reflect on our teaching practices and explore new approaches. We truly appreciate the time and effort you took to be with us and share your wisdom. Thank you once again for being a part of this FDP and for making it a memorable learning experience. Thank you so much, sir.
Okay, you're most welcome, and thanks everyone. Like for patient listening, because see, in fact, my area of expertise a little different, but since the topic is for sustainable material, I was compelled to take this session. But generally, I was more into designs, so I have done almost all kinds of structures, designed. Most of the irrigation structures, like all CM and cross masonry and cross drainage works, and pump houses and other tunnel linings. So almost I spent most of my tenure in the designs office, and I could do really good designs. And I also have an interest to share my design experience to all, and I used to take up classes. And this is a different experience for me to stand before you and could share my views in this area. Thank you. Thanks a lot, everyone.
Thank you, sir.
Thank you.
With this, we can close this session here. Thank you all for your patience and interactive, making this session very much interactive.
Yes.
Thank you once again, sir, and all the participants. Thank you.
Thank you.
Video.
Just one request to all participants, please make your video on so we can have a short screenshot here. Thank you all. Thank you, sir. Thank you all.